Next definition is otherwise excenter. Excenter. See, suppose the triangle is, so this is the triangle ABC. This is ABC. So if you extend these sides, this B and C. Now, if the circle, if you draw the circle which touches the three sides of a triangle externally, so like this, this is extended side. Now the circle which touches both the, so the circle external, the circle touches externally the triangle, then this is called as X circle opposite to the vertex A. So the circle is called as X circle opposite to the vertex A of a triangle. So the center of this X circle is I1. This is called as X center 1 actually. Because why X center 1? Similarly, if you extend this side and this side, sorry. So if you extend these two sides, you will have one more circle over here, X circle, and similarly here one more circle. Therefore, how many X circles are possible? 3 X circle. This is I2 and this one is I3. That's why this is X center I1. Now radius of this X circle, so this is R1, this is X radius. Sorry, R1. This is X radius of the circle. So this is called as X circle opposite to vertex A. This is X circle opposite to vertex A. So similarly, you will have the three remaining two X circles. Like this. Similarly, this side. Okay. So this is some I2. This one is I3. So, and this radius is some R2. This is R2, etc. The radius of the circle is R3. These are the X circles. So total, how many X circles are possible? 3 X circles. So 3 total X circles. 3 X circles. I will write like this. 3 X circles. 3 X circles. X centers 3. That is, X centers are I1, I2, I3. X radii R1, R2, R3. R1, R2, R3. Next, right. Next, again I will draw diagram. So for this, so this is the triangle. So this is the triangle ABC. So I'll extend sides. So this is X circle. Yes. So this is the X circle. Right. Now this is A, this one is B, this is C. So this is eccentre I1. Now, if you join, this is internal angular bisector of A and the external angular bisectors of B and C. So this is I1. So this is eccentre I1. So this is angle B. Now tell me, what is this angle? This total angle is what? In a straight line, total pi or not? Pi radians. Okay, na? Yes or no? This total angle is equal to what? This total is pi. So this angle is B. So what would be remaining angle?
180 minus B by 2.
Yes, 180 minus B by 2. Because this is pi, sorry, this is B. The total angle in a straight line is 180 degrees or pi radians. So this is B. This angle is equal to pi minus B. So this is external angular bisector. Therefore, this angle is equal to pi minus B by 2. Similarly, so this angle is equals to pi minus C by 2. This is one point. Right. Next, note. So note number 1, centroid and incenter. Centroid and incenter always, centroid incenter always lies within the triangle. Within the triangle. Within the triangle. Orthocenter. Orthocenter or circumcenter. Orthocenter, circumcenter may or may not lie within the triangle. So this is note number 1. See, so centroid and incenter of always lies within the triangle. That is obvious. We know that one. Next, why orthocenter and circumcenter may or may not lie within the triangle? In which triangles, in which cases orthocenter and circumcenter will not lie within the triangle? Means you take, suppose, obtuse angle triangle you take. For example, you take this triangle. So you take, so rough diagram actually. Yes, you take the triangle like this. Sorry, it's a obtuse angle triangle. So now if you draw a circle which circumscribe this triangle, that is, this is ABC triangle. So this is obtuse angle triangle. So if you draw a circle which passes through ABC, rough diagram, manage with the diagram. So this is the circle which passes through this thing. So here this angle is what? Greater than 90 degrees. So greater than 90 degrees means, so angle in a semicircle is 90 degrees or not? We know that. Yes or no? So this is the diameter of the circle. Suppose this is the center of the circle. Angle in a semicircle is what? Always 90 degrees. Yes or no? So, but if you take any chord here other than diameter, then the angle made by this diameter on the circumference of the circle, this is greater than 90 degrees. Yes or no? So in this situation, see, in this situation here, this is right angle triangle. So this is what? Not a right angle triangle, yes or no? It's a obtuse angle triangle greater than 90. Then what is the circumcenter? See, where circumcenter lies, outside the triangle or not? Clear for obtuse angle triangle. Suppose this A dash, suppose this is P and A dash and B dash. For this diagram, circumcenter is same, circumcircle is same, but circumcenter is outside. Clear? This point is okay, na? Right.
Yes.
Right. So for obtuse angle triangle, the circumcenter is outside. Similarly, for obtuse angle triangle, orthocenter is also outside. See how you take this obtuse angle triangle. So this is the obtuse angle triangle. So for this triangle, what is the definition of the orthocenter? The point of concurrency of altitudes. So here for this triangle, it's obtuse angle triangle. So altitudes, how will be the altitudes? So this is altitude means heights. This is one altitude and this is another altitude. This is a rough diagram. So this is another altitude and third altitude is this one. So this is another altitude. So the point of concurrency of altitudes is what? Orthocenter. Where orthocenter lies? Outside the triangle or not? In this situation, greater than 90.
Yes, sir.
So this is the reason. Yes or no? For obtuse angle triangle, the circumcenter and orthocenter lies outside. That is the meaning of this note. Next, note number 2. Note number 2. See, you take right angle triangle. So this is a right angle triangle A, B, C. So now for this right angle triangle, what is the what is the orthocenter of a triangle? The point of concurrency of altitude. Yes or no? So here for this right angle triangle, altitudes are what? This AB is altitude and CB is another altitude. The point of concurrency is B or not. Therefore, this itself. Therefore, orthocenter is just this vertex at 90 degrees for right angle triangle. Yes or no? This is orthocenter. For right angle triangle, orthocenter is the vertex where angle is 90 degrees. So this is the orthocenter. Next. So what is the circumcenter? Where circumcenter lies for the right angle triangle? See, the same copy I will take. So this is the right angle triangle. Now where circumcenter lies, we will see. Circle we draw first. A, B, C. So if you draw the circumcircle. Now where circumcenter lies, tell me. Angle in this angle is 90. Yes, because this angle is 90 degrees. Angle is 90 degrees means angle in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees means this AC will be the diameter of the circle. Diameter of the circle means the center of the circle is nothing but the midpoint of the AC. So no, this is the circumcenter. So here this one, this is the circumcenter. That's why for circumcenter of a triangle is nothing but the midpoint of the hypotenuse. So this is circumcenter. So this is orthocenter. So this is the point. And for I'll write one statement for circumcenter and write like this: midpoint of hypotenuse. Next, for right triangle, orthocenter and circumcenter. Orthocenter and circumcenter lies on the triangle. Yes or no? Orthocenter, circumcenter is on the triangle. And from this one, now tell me, for this circle, now circumradius is denoted by what generally? Yesterday we have seen. Capital R or not? Circumradius.
Yes.
So yes, this AM is here circumradius. This AM distance, this is circumradius, and MC distance, this is also circumradius. And if we join this B and M, this is also circumradius, because the distance from the point on the circumference of the circle to center, this BM is also R. So from this diagram, we will write this one. AM is equal to, from this diagram, AM distance is equals to BM distance is equals to CM distance is equals to R. What is this R? Circumradius. And this R is equal to what? So yesterday I have given the notations. The side length of the side opposite to the vertex B is denoted by small b or not? Yes or no? This AC is equal to what? From this diagram, this AC length is equal to small b. That's why this R is equal to what here? Small b by 2. Na? Clear at this point? Small b by 2. Yeah. Next point is, see, right. So you take any triangle. So this is the triangle ABC. So this M1 is the midpoint of AB. M1 is the midpoint of AB, and M2 is the midpoint of AC. Now you join this M1 and M2. So this M1, M2 will be M1, M2, M1, M2 will be parallel to BC, and will be half of it. So this is the next point. So you memorize these few points. So you can prove easily. To prove this result, we will take the coordinate axis help, that is our reference frame. So we can prove it easily. To prove it, what you do is, you take the simplest triangle, that is simplest vertices. You to prove anything in general, you try to prove as simple as possible. Yes or no? So that's why to prove it, we will use the coordinate axis. Yes or no? Don't take the general triangle. Therefore, you don't take the vertices as x1, y1, x2, y2, x3, y3. So by taking the vertices as x1, y1, x2, y2, x3, y3, you can prove, but it's a very lengthy, it's a tedious process. So instead of taking the x1, y1, x2, y2, x3, y3, you take the points or vertices of a triangle as simple as possible. For that one, what I do is I will take the B as origin. Yes or no? You take this one vertex, this B as 0, 0, and you take C on x-axis itself. You take this one A, 0. Okay, na? A, 0. And you take the another point, that is vertex A, you take on in first quadrant. So I will not give the complete proof. You can prove by yourself. You simply prove it. You take this one, some already A have taken. So B, C. Okay, na? B, C. So you find the midpoints M1 and M2. We know the midpoint formula. Is that no? So what you do? B plus 0 by 2, C plus 0 by 2. Here B plus A by 2, C plus A by 2, like that. Yes or no? You will get this M1, M2. Then these two are parallel. Parallel means slopes are equal. So calculate slope of M1, M2 and slope of BC. Those two slopes will be same. And M1, M2 will be half of the BC. You calculate BC distance and M1, M2 distance. So M1, M2 distance will be half of BC distance. You do this as homework. Okay. Result is note number 4. Suppose I'll write note number 4 over here. Note number 4. See, you take a triangle. Suppose right, this is the triangle. So in this triangle, what I do is first I will draw the altitude. So this is the altitude. Right, means this angle is what? 90 degrees. Next, what you do is you draw the median. So median means here exactly you take the middle point. So this is M. You join this A and this median. Next, what you do is next you take perpendicular bisector. Perpendicular bisector will be like this. Yes, sir? So this angle is 90 degrees. This angle is 90. This is A, B, C. Now what I have taken? I have taken altitude and the median and the perpendicular bisector. Now tell me, so orthocenter lies on altitude or not? Because the orthocenter definition is what? The point of concurrency of heights or altitudes. That's why orthocenter lies on this line. So suppose this is the AD line. Orthocenter lies on AD line. That's why you call this as orthocenter. Next, centroid lies on median, because yesterday we have seen the point of concurrency of medians is what? Centroid. Therefore, centroid lies on median. So call this as centroid. Next, what is the point of concurrency of perpendicular bisectors? So perpendicular bisectors, circumcenter. That's why circumcenter lies on this angle is 90 degrees. Circumcenter lies on this line. That is perpendicular bisector. So what is the notation for circumcenter? O. Yes, sir. O. So now we have one result. This in a triangle, orthocenter and circumcenter and centroid and circumcenter are collinear. So this is the result we have. So it's a very, very important one. So this is centroid. So orthocenter and circumcenter and centroid are collinear. So we'll name this thing. So what is this? This is orthocenter. Orthocenter. So this is centroid. So this is circumcenter. This is circumcenter. So this is M is what? Midpoint of BC. Because it's a median. AD is a median. That's why it's a midpoint of BC. So now here, now if you observe this diagram, in this diagram, from this diagram, AD line is parallel to MO line or not? So this is AD and MO. These two lines are parallel because this angle is 90 degrees. Therefore, AB is parallel to MO. That is the first thing. AB line is parallel to MO and BM distance is equals to what? This distance. BM distance is equal to MC distance. Or BM distance is equal to MC distance. MC distance. Next, from this diagram, so triangle AHG this triangle, the triangle, this one, AHG and MOG. These two triangles are similar or not? These two triangles are similar. Angle AHG is similar to triangle MOG. Similar triangles. Similar triangles. Therefore, if the triangles are similar, then ratios of sides, that is AH side over OM. So no, this AH over OM is equal to HG over GO is equals to AG over GM. We'll write that one. So AH or OM is equals to HG over GO is equals to AG over GM is equals to. Now already we know that from school mathematics or plane geometry, centroid divides median in the ratio of 2:1 internal. Yes or no? Centroid divides median in the ratio 2:1 internal. So that is AG by GM. See, this AG by GM is equal to what? 2:1. So this is equal to what? 2/1. So now what I do is, yes. Now from these two things, what can we write? AH is equals to 2 times OM. AH is equal to 2 times OM. So next HG is equals to, so HG is equals to 2 times GO. So HG is equal to 2 times GO. What is HG is equal to? That is this one. HG is equal to 2 times GO. So this distance, HG distance, 2 times of GO distance. Means this HGO are collinear or not? Yes or no? That implies the meaning of this one, H comma G comma O are collinear. So this is an important point. Means in a triangle, orthocenter, centroid and circumcenter are collinear, and that too centroid divides, because HG by GO is 2:1. HG by GO is 2:1. Centroid divides orthocenter and circumcenter internally in the ratio of 2:1. Therefore, HG are collinear. Next one is, if we draw in one diagram, this is orthocenter. Yes, sir, from diagram, I have taken outside that line, HGO line. H is this one. So G is this one. O is this one. Remember is this one. So this ratio is what? 2:1. Sir. Therefore, we will write one note. In a triangle, orthocenter, comma centroid and circumcenter are collinear. And centroid divides divides orthocenter. I'll write like this. Centroid divides join of orthocenter and circumcenter. And circumcenter in the ratio 2:1. In the ratio 2:1 internally. So this is one result.